Hello, in this video, I will explain how quadratic function can be used in the real world. I will explain how to solve word problems using quadratic functions. So now we're going to apply it to the real world. Yeah. So word problems involving quadratic functions. So quadratic functions can be applied in the real world, such as throwing a ball on the ground level or on from top of a building. So that's more like physics related, but yeah, it's all physics related. Or another scenario would be shooting a cannon because so for example, scenario one, throwing a ball on a ground level or on top of the building. So here you are, here's the building, here you are, and then you threw a ball. So this ball actually forms a upside down parabola, upside down quadratic function, right? So that's how it could be related. Diving from a platform, right? It's an upside down parabola. Hitting a golf ball in the business world, it's like finding the maximum profit. So basically anything that has an absolute max or an absolute min, you're going to have, it's related to quadratic functions. Okay. So how would you, steps for solving word problems involving quadratic functions? What I would do is first I would write down everything you know about this problem. Even if you think it's not useful, just write it down because it might be useful. Then what I would do is after I wrote down everything I know about that problem, I would draw the best image you could think of. Try to figure out what would be considered the x values and the y values because you're most likely going to graph it. So yeah, just try to figure out from the piece of information what would be considered the x values and what would be the y values. The problem might not give you out the problems might not give out coordinates immediately, so you will have to figure out the coordinates. Okay, and then figure out if the graph of the quadratic function is concave up or concave down, because that's extremely helpful when you've got to find your max and minimum. And figure out if the problem is asking for the x value or the y value of the vertex. So usually at the end of the question, you're either finding the x value of the vertex or the y value of the vertex. Okay. So let's start with example one. So example one says a ball is shot from a cannon into the air with an upward velocity of 40 feet per second. The equation that gives the height h of the ball at any time t is h of t equals to negative 16t squared plus 40t plus 1.5. Find the maximum height attained by the ball. How long does it take the ball to reach a height of 20 feet? So they're asking two things. Find the maximum height attained by the ball, and then how long does it take the ball to reach? So what would I do? So, okay, since we're going to graph it, let's kind of graph it. What would be considered our x values and what would be considered our y values? So I believe our x values are going to be time. Yeah, I believe our x value on the x-axis is going to be time. So x is going to be time. And what do you think the y value is going to be? I believe it would be height. Height, we are in feet. Okay, so that is first thing. That's what's first thing I would do, figure out what would be considered the x and y. So y is height. And they tell us that we have a quadratic function h of t. Okay, so let's start with the first question. So the first part of the question is find the maximum height. So the key word here is maximum. That means it is related to a vertex, right? So the real question is it the x value of the vertex or the y value of the vertex? So we distinguished that height is the y value. That's what we said here. So we got to find the y value of the vertex. Okay, so in order to do that, we got to first find the x value of the vertex. So how do we find the x value of the vertex from this given equation? Since it is in standard form, you would have to do the formula, find the x value, you have to use the formula x equals opposite b over 2a. So let's first figure out our a, b, and c. So our a is -16, my b is 40, and my c is 1.5, correct? So we just put it in this formula. So x equals opposite of b over 2a. So the opposite of b is -40. And then it's 2 times -16. 2 times -16 is -32. So when you put it all together, you get 40 out of 32, which can be reduced by 8. So that is 5 over 4. Or what is 5 over 4? Because we actually need a value. It is going to be, hold on. Right, so 5 over 4 is 1.25, so you're going to plug in 1.25. So 5/4 is like exactly 1.25. So now we're going to find the y value of the vertex by plugging t for 1.25, right? Okay, now let's put that in. Which is 26.5. So that's our answer. They're asking what is the maximum height by the ball. So if you drew this, it's concave down, right? So the x value of the vertex is 1.25, and then the y value is 26.5. So you could say, we'll write it as a complete sentence. Maximum height of 26.5. Okay, so that is the first part of the question. The second part of the question says, how long does the ball reach at a height of 20 feet? So I don't know, 20 feet, this is 26, so 20 feet would be right here. So they're asking for a time value. So there might be two times, right? Let's pretend this is 20 feet. I'm just approximating. So that we have a time here and a time there. So we might have 2 times. Okay, so how would we do that? How long does it take for the ball to reach a height of 20 feet? So you just replace h of t with 20, and then you get -16t squared. then we just solve for t, so I'm going to subtract 20. So I get 0 equals to negative negative 18.5. Okay, and then we got to factor this by using the quadratic formula. So my a value is negative 16, my b value is 40, and my c value is negative 18.5. So quadratic formula is opposite of b over 2a. So your t value is going to be opposite of b, so it's negative 40 plus or minus root. B square is, well, b is 40, b square would be 1600 minus 4 times AC, so A is negative 16, and C is negative 18.5. All over 2 times negative 16. I'm going to save you guys work, so I'm just going to put it in, and when you do all the work, you should get 2 times. One would be, I'm just going to round to the nearest tenth, so 0.6, and our other time is 1.9. So if you have a time that's negative, you could exclude that value because we can't go back in time. It makes about sense, right? This is very close to 0. And then you have another time at 1.9. Okay. So that's the second part of the answer. Okay, let's move on, or go ahead and pause to copy down any work. And let's move on to example 2. Okay, so example 2 says Abraham throws a ball from a point 40 meters above the ground. The height of the ball from the ground level after t seconds is defined by the function h of t equals to 40t minus 5t squared. How long will the ball take to hit the ground? Okay, so they tell us that our function is right. Then what I would do is maybe draw an image. So throws the ball from the point of 40. So you're on some kind of cliff or a building. Whatever it is, the length is 40 feet. Okay, so this is length is 40 feet. Here is Abraham. He throws a ball from 40 feet above ground. So he throws a ball like this. And as you can see, it shows a upside down parabola, or yeah, concave down quadratic. And what is it they're asking? They're asking how long will the ball hit the ground? So they're asking for time. So what do you think is time an x value or a y value? So if you graph it, just like our other one, on the x-axis, I'm going to label it time. And then on the y-axis, it will be considered my height. So we're actually solving for the time, so it's like related to the x. So my question is, what would be the height when it touches the ground? When the ball touches the ground. So once the ball hits the ground, the height will be 0. So really, here's your upside down parabola. So it's basically the x-intercept you're looking for. And I don't think we can use the x value 0 because that means you haven't moved at all. So I would replace h of t with 0 because remember, if we're finding the x-intercept, you set y to 0, right? Go ahead and solve for t. So as you can see, I think I could factor out a negative 5t. So this is going to be t minus 8. And then solve for t, so set each equation to 0. So negative 5t to 0, and then t minus 8 to 0, right? Solve for t, so you're going to subtract negative 5, negative 5. I get t equals 0. Over here, I'm going to add 8, add 8. So why could we exclude 0? Because at 0 seconds, you haven't moved at all. So that just wouldn't make sense. So I think our only answer would be t equals 8 seconds. Okay. Let's move on to example 3. Okay, the area of a rectangular pool is 1260 feet. Find the dimensions of the rectangle if one side of the pool is 48 feet more than 3 times the other side. So that sounds very confusing, right? I'm going to read it again. So the area of a rectangular pool is 1260 square feet. Find the dimensions of the rectangle if one of the side of the pool is 48 feet more than 3 times the other side. So I'm going to draw an image. I'm going to draw a rectangular pool. So this would be my length. This would be my width. And what else do we know? We know that the area of the pool is 1260. So what is the area of a rectangle? Area of a rectangle is length times width. And then you can replace A with 1260, right? It says that find the dimension if one side of the pool is 48 feet more than 3 times the other side. So I think they're describing the length. So from that piece of information, if one side of the pool is 48 feet more than 3 times the other side, how do I write that as an equation? 48 feet more, so that's like plus 48. Then 3 times the other side, so the other side's the width, so that would be 3w, right? So I guess you can replace the length with 3w plus 48. And then we'll label w as w for right now. Okay, so it's going to be area equals to length, which is 3w plus 48, times it by the width. So yeah, and then replace A with 1260. Right? And then just FOIL it out. So this would be 3w squared plus 48w. Okay, and then I'm going to solve for w, so I have to get one side 0 because I'm going to most likely factor. So subtract 1260, subtract 1260. So I get 0 equals to 3w squared plus 48w minus 1260. Okay, and then got to solve for w, so could I do something? Can I get rid of this 3 by dividing everything by 3? Yes, I believe everything is divisible by 3, so divide everything by 3, including the 0. So 0 divided by 3 is 0. This would be w squared plus 16w. Negative 1260 divided by 3 is negative 420. Okay, factor this out. Uh, what two numbers multiply negative 420 and when added gives you 16? It would be W plus 30, W minus 14. Okay, when you actually solve for W, you're going to get negative 30 and W equals to 14. Now, we have two possibilities. Is there one that you can get rid of? Yes, you can get rid of the width of negative 30 because it just doesn't make sense to have a negative length, right? So let's plug in, let's actually find our length because we know what W is now. So length is 3 times W, so 3 times 14 plus 48. So that's 42 plus 48. That's 90. And then our width, we said our width is 14. So our length is 90 and our width is 14. Now we got to check. So we know that area equals length times width. So area equals to length, which is 90. And my width is 14. And they say that our area is 1260. So on the right, 90 times 14 is 1260. So the left does equal to the right, so it is true. So that means this concludes that our length is 90 feet and our width is 40 feet. Yep. Go ahead and pause, and then we will finish the other two samples in another video. Okay, thank you. Bye-bye.